Shifting right will essentially be the opposite of this. So I'm going to just take all this stuff and move it over here. Now, whereas on the left side of it, we're worried about 0 and being greater than 0. On the right side of it, we're worried about the width of the game and being less than the width of the game. So the next thing we have to identify is, well, what is the end of this line shape? And I will take us back to the Visio. So if I turn this like this, and let's assume that this was the line shape, and I'm starting over here on this shape, then the end of this shape is basically this value plus 1, 2, right? And what we're trying to see if this value plus 3 is greater than, or has, I'm sorry, if this value plus 3 is greater than the end of the game width, or if this value plus 3 is occupied. That's what we're doing on the right side, right? On the left side, we're doing if this value minus 1. On the right side, this value plus 1, 2, 3. Okay. So left plus 3 should be less than the game width. So even though we are correct, and that works for in the horizontal mode, in the vertical mode, it's a completely different set of rules. So we actually have to bring this code down here. And then for the vertical mode, it's completely different. So we've been doing left minus 1 for all the vertical ones. This is going to be left plus 1. I don't know what just happened. Yeah, so for vertical, this just works, right? And I can now do this, something like this. Left plus 1 is greater than, less than. So all of these must be true. And then on this side now, this is where it comes in. Because on this side, then all I need to do is bring the if statement at the top into the horizontal line scope. I think this does it, and I don't really need that. We're going right. We'll test that in a second, but let's just go through and make sure that our logic is right. So when I'm in vertical mode, then I just want to make sure that if I add 1 to it, that it's less than or equal to the game width. I think it just has to be less than. And the same thing here. That's it. So is it game width? Is it less than the game width? And also, are these things not occupied? Then I can move. Then over here, when it's in its horizontal form, then it's left plus 3, because looking at how I draw it, let's just check along with how I draw it. When I'm drawing horizontal, it's left plus 1. So 1, 2, 3, 4. So left plus, so I'd be left here. So this is it. So this place. So in horizontal, I start here. Plus 1, plus 2, yeah, plus 3. Yes, plus 3. Okay, so that's how I draw it. So left plus 3. And then same thing, left plus 3 is occupied, is equal to false. All right, let's see if this works. Just add the shape. And we go left. We go right. Yay, so left and right are working. See if they work to the end. And do they work to the end? Well, we know this is gonna work, but we haven't done the other, right? So now we gotta rotate it. Now for can rotate, what do we need to do? And there is one mistake I'm making here. So when I'm drawing it vertical, I'm starting with top instead of top minus 1. So this is really what it should be. Top minus 1, top plus 1, top plus 2. Right, that follows the same format, a left minus 1. So that way that second item is always the main item, not the first. And in the game field, that means that actually in the game itself, that means that, well, let's start with 2, just so I have enough room to play around with. Okay, so that just takes care of that. All right, so let's go back here. So how does that change anything? This is just for the straight thing. It really doesn't change anything here because everything we've done, everything that requires, we've only done left and right movement. So in a horizontal mode, it's always checking plus 1. That's it. So now can rotate. Rotating a shape essentially follows the same pattern as shifting the shape left or right. We basically look at how the shape is going to be positioned when the rotation has completed and ensure that none of the blocks that make up the shape are occupied. The big distinction here is that the primary block doesn't move. So by definition, it will be occupied. So we're really only checking the blocks to the left of it and to the right of it, or to the top of it and the bottom of it. Okay, and I believe we can go right, and I believe we can go left. And let's go. Can we go left? All right, so let's see if we can fix this issue here. So I'm getting a -1 because over here, I've now switched it so that everything is keyed off of this middle thing guy. So when I want to see the end, I want to know 1, 2. So I want 2 passed. I want to see if that is available. But I first have to check if that is less than 0. So if Okay, so column minus 2 must be greater than or equal to 0, or basically it's false as well. So add shape, let's rotate the shape and let's see if that works. Yep, so that stops me. All right, now let's do the right side and see if we got that figured out. Yep, so left and right are figured out. Now let us rotate the shape. Now let us try rotating the shape. That should not work. Rotate the shape, rotate the shape, rotate the shape. Well, it doesn't work there, but it works, definitely works here. Rotate shape. Let's go over here and see what's happening. Now, these errors are mainly occurring because the rules around the boundaries are not necessarily being set right as we're going through the application. You are welcome to look at the code base, which is on GitHub, to find the exact rule set that you have to have in place in the if statements. What I'm doing here is basically setting the boundaries around the right and the left side of the game, such that if for any reason searching for shapes outside the boundaries occur, then we can presume that that's a scenario where we can't go there because it's not actually inside of the game boundary. I think that covers it. So if I shift left, then I can rotate. That's it. I can rotate. All right. All right, so it looks like we have movement to the right, movement to the left, rotation, which is awesome-tacular. Now I'm going to go back to the game field, and I'm actually going to set the okay, so this is going to be a okay, so I'm actually going to set this because I want them to be squares. Right now, they're not squares. Right now. Let's see how this looks if I all right, so much better. Okay, so over here, the width is gonna be 20, and the width here, I'll make 15. It's starting to actually look like the kind of surface that we want. There we go. Now I want to add a shape. Looking pretty good. Move it to the right. Move it to the left. So let's close some things. Let's reset our our desktop here. And now let's look at the ability to descend. So for descending, what do we want? We basically want to make sure that what's underneath us doesn't have any wedging in it. So this is really where it's going to matter whether things are occupied. It's more than likely you're going to be hitting the boundaries when you're going left and right. More than likely you're going to actually be hitting the boundaries of the game. But when you're going down, you're definitely going to be going down until you actually hit either the bottom of the game or you hit another shape that's been wedged right within a line. So this piece we've got to get right. And again, we're going to be doing the same sort of thing, right? It's going to be different based on the axis, as you might imagine. Right. And then there's two axes that we're worried about. There's the horizontal. And there's going to be there's a vertical. I made the mistake once again. And here's the horizontal. And then we're going to return false by default. So first we're going to do the horizontal one. So if the field, so it doesn't matter. So it's left -1. Why is this giving me problems, bro? Oh, it's column. Okay. Sigh. Okay, so we need all of them. So I'm going to add this one here. So if column -1, column +1, column +2, and then I'm checking for all of them row +1. So basically, what am I doing here? I'm checking to see if the next row, when it's horizontal, if the next row down, if anything is occupied in the next row down, then I can't move down there. Otherwise, I can. It's pretty straightforward. And this should allow me to basically add shapes and pile shapes on, and we should be able to check that out right now. Now, if it's horizontal, if it's vertical, it's a little bit of a different flow. For vertical, we essentially just want to make sure that the third one down from the top is basically so it would basically be the column. And then we go the row +3 is occupied. Is equal to false. Then we will return false. Let's go through and see if this works. Add a shape. Ooh. Why are we wedging? Words can descend. All right, let's try this again. Okay. Voila, we're wedging because that should say true. All right, let's get rid of that. Add the shape, and we are going down. add another shape, and we are going down, and we are wedging. Perfect. Okay. Progress is being made. Progress is being made. For the wedge, I'm just gonna comment that out so we don't get the exception. Okay. So let's go through this bad boy and see it working. So I can now add a shape. I'm gonna rotate the shape, and I'm just gonna drop it all the way down. That works. Add another shape. Drop it all the way down. Works. Add another shape. Rotate it. Drop it all the way down. Works. Add another shape. Let's move it to the right a bit and drop it. And I think you get the point here. This basically move it to the left and then bring it down. There we go. And let's see if, and then go past that. We should be able to get past that. Bring it down. And then now I should be able to go to the right, which I can. And I can't go any further. I should be able to go down, and I should be able to go right again. Right? So we've got this thing humming here. And our rules are working quite nicely. And then let's see if we can rotate in that situation. So let's go in here. Let's go down. Let's go to the right. See if we'll rotate will work. No, rotate does not work. So go down. So we get the picture here. It's working. We can descend, and this works. Well, I know why it's working, because it really doesn't matter. But for the purpose of this application, just leave it at that. If there's space for it to switch shape, to shift shape, it's really not rotating, it's really shape shifting. This is a shape shifting thing happening here. So it fits in. All right, so we're good. So we got descending. Do we have everything? We got shifting left. We got rotating. We got shifting right. We got the ability to clear, ability to draw. And now all that's left is the wedging, right? So what is wedging? So, and why do we need to call the function here? Because again, remember that once a shape hits the bottom, and we can start it right here. Once we add a shape, once that shape drops to the bottom, then what we want to happen is we want for, once it hits here, we want it wedged. And when it gets wedged, then it's no longer a shape. It's now 4 lines, each line having 1 block inside of it. And the objective being to fill up this whole line, and then that line, basically getting a score for filling up that whole line, and that line essentially disappearing. right? So we need an indicator of when a shape is wedged, any shape is wedged, because that's going to be an opportunity for us to go through all the lines in the game field and basically find if any lines have been filled, right? Anytime a shape is wedged, we check all lines. And so obviously if you wedge a shape and there's four and you wedge it, let's say there was a full block on both sides of this and you wedged it, then four lines would need to be scored against, right? And would have to disappear, and then everything else drop once it disappears. So that's the purpose of calling the wedge method, right? So when anything hits down, it's a chance for us to get that going, right? So, and as part of that, we're gonna need something to basically manage the lines that we're going to be tracking. So let's go ahead and let's add a new library item, class. We'll just call it line manager. That's a good enough name. And the purpose of this class is basically to do that, to do the tracking, right? So obviously for every single line, let's create a thing for it. We're gonna need the width of the line, whatever that is. We're gonna need the line number, and we probably want to pass in the game field so that we can see what's going on in the line. And I'm just gonna I'll just save it to a field. Okay. And then basically I'm just setting these things to local variable, nothing special. All right, that's pretty good so far. And then what I'm also gonna need is some kind of way that I can represent the blocks that are in that particular line. And I don't want to use the block control itself, just because I don't necessarily need to carry all that information with me. And again, remember that the blocks remain, right? So a block is not something that goes away. A block in our game is essentially a pixel, right? So we can't just delete it or null it or whatever, and we really don't want to mess around with it. So we really want a representation of the position of that block, which I think would be a combination of the line number, right, which basically is the top, and the position within that line that the block is in. So we just create, I usually use a pattern where I just call it an info. So public class block info, and call it the column. I was going to call it left. We'll call it the column, and so save the color of it. Okay. So why is this? Why is it important to save the color here? As you notice that I'm saving this color information. So the reason why I'm doing it, and I'm just thinking through this as we're going along, and so apologies if I'm not talking through the whole thing. But the reason why we save the color is because when we run this code, right? Remember, every single shape is gonna have its own color, right? And right now, I'm just adding one shape at a time. So descend that, right? But theoretically, there may be multiple shapes with multiple different colors. Not even theoretically, there will be multiple shapes with multiple different colors. And again, the general purpose of what we're actually doing right now with this line manager is we want to implement the ability to wedge. And part of the ability to wedge is basically the ability to identify when a full line has been hit, and then that line needs to be removed. And after that line is removed, all subsequent lines need to move down one, right? So in order for us to maintain that illusion, we basically need to maintain the colors, right? So if this item was green up here, when it moves down here, it needs to also be green, right? So that when we, when we ask the block to display something, right? Just put a color on that block. We want to make sure that the right color is put on the block. We can't simply just move the blocks down, the actual physical blocks, because the actual physical blocks are pixels in this game. They're not a part of what a shape is. A shape is completely different than these blocks. So we need some representation of each individual item so that we can replicate it anywhere that we so desire, right? And that's what this is doing. The shape kind of does it, but the shape does it in a certain structure. We need a way to do it, just so we have that information. So if we need to do it somewhere, we can do it. So that's the reason why we're actually storing the block info. And so next thing is like what are the blocks that are going to be in a given line, right? So actually I don't need that to be public. So I'm just going to use a list for this. So use block info, line blocks or something like that. Right. So the block info would have the column. So as each column as things get wedged to this thing, they're going to be added to this list. And I'm trying to think now. I don't know why I don't use an array here. I think array might be better. But basically, when width is hit, that's when I know that line is full. And when that line is full, then I'm going to have to do whatever I need to do. But I don't want to I don't want to make it too complicated right now. So let's go ahead and let's go back to the wedge. Let's do wedge. That's where we were. Let's do wedge. Okay. The line manager that we're going to create, I would imagine it needs to exist here as well. So let's change the name. Let's actually change it here. So line manager seems to not be the best name. So I'll call it a field line manager. Gotta change it everywhere. And then there we go. So we now have that line manager all set up. We can put it in a game field or we can put it in load components. I will just put it here. Line manager equals new. Is that what I need to do? No, that's not what I need to do. This only manages one line. So this actually needs to be a list of line managers. And new. Yeah, there's going to be one line manager for each line. And that means that in our load components, which we're in right now, we also need to add the line manager associated with each row. Okay, so line managers to add. And this would be a new line manager. And the width is going to be the game width. And the line number is going to be the game row. And the field is this. That's nice. That's nicely done. I'm going to rename this to line managers. Okay. So I'm doing this basically because each line manager is going to map to one row. Now that we have that, let us go back here. And so we're doing wedging over here. So wedging would obviously be different based on how it's set up. What I mean is that if it's vertical like this, then you're creating 4 lines. Then you're putting things in 4 lines. If it's horizontal, then you're putting 4 things in 1 line. So based on how it wedges, depends on where the actual blocks of that shape go, right? So pretty straightforward, I think. So why do I always do that? And it's going to be the same old, same old. You have 2 cases. And boy, I tell you, you guys might want me to just do, in fact, I think that's what I'm going to do. I think for the other shapes, I'm going to just do them in fast forward because it's going to take hours for me to figure out, not hours, but it's going to take a while to like figure, to like go through and find all the various combinations for everything. The code is going to be available so you guys can look at the code, and of course I'll walk through everything once I've gone through and got everything working. But I don't see a need to like for you guys to sit here and watch me typing a whole bunch of stuff, right? That's essentially just the same pattern that's being followed here, just different shapes, so different squares that you're checking, right? But you understand the pattern. So this 0 and 180 is vertical. And for vertical, we are going to basically add it to, oh man, I didn't make this public. Let's go back up here and make it public or internal. Well, I'm not worried about that right now. So line managers. Oh man. I need a way here to basically add. So what's happening here is kind of thinking way ahead of myself. So I've got my line manager set up, but my line manager does not, but I've got to be able to add the, this particular shape into the line manager, right? I've got to be able to add the block associated with this shape into the line manager, not the whole shape, because again, remember the shape is made up of 4 blocks, and I need to know what the background color of those blocks are, which is basically going to be the background color of this shape. Not a big deal, but I need to know what position they are. I already have the top, right? The top is going to be the row or row plus 1, row plus 2, and then the left is going to be either left or left plus 1, whatever, depending on the axis. So over here, to register a shape block. It's a block info. Block info. I never added a way to add this guy. Okay, and that's all this is gonna do. It's just gonna register the shape block. I'm not gonna actually do any stuff there. It's here that I now need to register the shape block, and it's gonna be a new block info. It'd be nice if I could add a record there. So this is the vertical one. So in the vertical one, left is gonna be the same everywhere. The column is gonna be the same everywhere. Okay. And the color is going to be this, that, shape background. So remember what we did here? For vertical, it's row minus one, row plus one, row plus two. So basically, that's the flow. 1, 2, 3, 4. Row minus one, row plus one, and row plus two. So all I'm doing is I'm adding, when it's vertical, I add it to these various lines, right? In the line manager, I add this block info to those various lines in the line manager. And when it's horizontal, I'm going to be doing the same thing, but it's going to be getting added to its row. It's not row that's going to change. It's left or column that's going to change, right? So it's the same everything, but it's all the same row. And now it's going to be column minus one, column plus one, and column plus two. Okay, so now we have the blocks registered. We can now go back to the line manager and we can start doing some cool things with it, right? Because we know how many blocks need to be in a given line based on the width of the line manager, right? Which is determined by the width of the game. So I can now essentially say right, and that would be determined by right. So if those two things are the same, then I know that the line is full. With the information that I have now, as you can see, it's relatively straightforward to go through and create a clear lines function. I'm essentially iterating through the line of blocks which get created each time a shape gets wedged. And for each of these block info objects that I have, I use the column and the line number associated with this line manager to basically identify the individual block, and then I just call clear on it, which should clear the block and return it to the background color of the field itself. A shift down function should also be added to this class. Basically, all this does is take every single line above the line that has been cleared and shift it down one line. It does this in a recursive manner. First, I check to see if the line that I'm currently on has any blocks in it. If there's no blocks in it, then it just passes through and it ends the recursion. This is the gate for the loop that we're creating. Inside of it, if it does have an actual count, meaning that there's some blocks inside of it, then I'm going to do two things. First of all, I want to check to see if the line above this line has any blocks. If it has any blocks, then I'm going to clear this line and I'm going to copy all the blocks from the line above into this line and then basically redraw it. If the line above me has no blocks, then I'm just gonna clear this line. If the line above me has no blocks, I essentially do the same thing. I clear the line and basically reset the line that I'm currently on to the line above me, which in this case would basically be nulling out the list to 0. But in this case, since I'm clearing the line and I know that there's nothing to draw, I basically don't redraw it. To optimize this, we could take the clear line and line reinitialization out of the if statement, since regardless of what branch you go down, you're going to have to do that. Finally, once I'm done with either branch, I come down and basically recursively call the shift down method for the line that's above me. This process continues on until I encounter a line with no blocks in it, at which point the recursive loop ends. Right, let's try to integrate this and see it fully working. So right now we add shapes here, create a current shape, and then in here we should be able to call the wedged event. Like that. So basically, when a shape is wedged, we basically want to do something here. I'm going to move this into game because I don't want this to be loose, okay? So I'm going to move it into game, into add shape. Okay, and let's just create a call it active shape. So the active shape is going to be the main shape. Remember, we have to do a preview shape. So now I like this part being here, but I'm not convinced about this part. So I'm actually going to move this guy out and put it here. I didn't quite do that right. That's what I wanted to do. That's what I wanted to do. Then in here, I think that stays the same. And that stays the same. Yep. This is how I wanted it. So basically, the main window is going to continue to create the shape. It's not really coming from the game field. But the game field does need to know when a shape is wedged because it does things based on that. We want to keep all that stuff internal. When a shape is wedged, right, we kind of want to evaluate the lines, right? We want to know which of the lines has been modified. You know, we might need to apply rules. Who knows what the reason for it is? But we really want to go through and find out if any lines are full, and if any lines are full, then basically we want to shift, clear the blocks or clear the line, and basically that will start the whole process, right? So so we're evaluating the lines. All right, I was thinking of using a number about range, but that's not going to work. So I'll just use the regular for loop. Okay. And line is greater than 0. This is pretty cool, bro. This is like reading exactly what I need to do. I don't have to do anything, right? Okay. There we go. So we have our line manager, and now we can check if it's full. And if it's full, then we basically clear it. And that would do all the shifting down and everything that needs to be done. And just to make sure of that, let's see. That clear line does do just check if it's full and does shift it down. We almost don't even need checking if it's full, right? We can just call clear line. Yeah, I don't like that. I like this approach better. So over here, I'm gonna get rid of is full because it's basically unnecessary. Actually, I'm gonna keep it because if you can call clear line by itself, then I want to make sure that no matter what, it does not clear the line unless it's full. I'm probably on the game field right now. If it's full, there probably needs to be an event. So I'm going to add an event. Right. And then that event basically be called and we can talk about that later on. So basically this is going to clear the line, do everything it needs to do, and move it down one. And I think what I may need to do, just looking at it, I may need to restart again. Right, and that's because as you shift it down, well, let me see, is it going to affect anything? I'm not sure if it's going to affect anything. We'll see what happens. But there may be a need for us to basically restart again, restart the loop again after everything comes down. But as it stands right now, once we have this, we can call evaluate lines. Once it's wedged, we can call evaluate lines, and that should pull everything down. Here's the final version of evaluate lines. Basically, we continue to use the for loop and pull the line and the line manager from that line number. We check to see if the line is full. Inside of is full, we actually clear the line and shift down, so we don't do it in the program itself. I switched it around. It seems to work out much better when running like this. And then there's some scoring related things, which we'll talk about in later videos, but basically we increment the score and propagate the fact that the score has changed to any event listeners. And then if you look at the bottom, we do set the line back to game height in situations where we find that the line manager is full. Okay, so these two should go. That should drop with that. Let's see if that works. Yes, finally. All right, and we go down. And we go down. I'm just gonna try to finish this up just so we can say we have everything working as it should. And then oh, that'd have been so I'd have been so mad. All right. So we got the physics working here. So what I'm gonna do now is go ahead and create the other shapes, and I'm just gonna create all of them and fast forward, and then we can reconvene and continue with the video once it's all done. All right, so I got all my shapes created now, and I've got them all instantiated, following the same process as the eye shape, basically inheriting all these methods and implementing them using the blocks collection. I've also added the appropriate color for each one. Couple notable things: the O shape, basically, because it's the same shape no matter what. Can rotate is just true. There's really no change, and obviously for some of the shifting it's a lot simpler. But they all basically follow the same pattern, and again, the code is gonna be on GitHub for people to play around with it, and I'll leave the links in the description so you can go look at it, modify it, do whatever you want to do with it. Just whatever you do, do not publish it as a, as a clone, because again, there are serious ramifications to doing things like that. So this is more for playing around at home. It's really not for creating any kind of commercial product. And if you were to create something like that, I'm sure you'd get a letter at some point. All right, so we are basically all set with this, and we've got these shapes set up. So we can now try these individual shapes and just see that they work properly. And we're starting to see that the game is actually taking shape right now. Taking shape quite well. And this can go down there.